Hello everyone. In this video we are going to look at things which are equal. Suppose we take algebra. If you talk about things which are equal, it just means that something being equal to another thing means that the quantities are the same. The quantities of those two things which we are talking about are the same. But here we are going to deal with geometry. Geometry talks about shapes. So when can one shape said to be equal to another shape? One, the sizes of the shapes should be the same and the shape itself has to maintain. The shape has to be maintained. Only then we talk about two shapes being equal, or the other word used for being equal is being congruent. So congruence is nothing but the shapes are exactly the same when superimposed on one another. So now let us look at congruence in a more clear way, and here we are going to talk about congruence of triangles. So consider this triangle, and now we have another triangle which is congruent to this. So this is the other triangle which is congruent. Now how do we check? How do we check whether they are congruent? Let me take this triangle and rotate it and shift it. Rotate it and shift it to superimpose on the other triangle, to place it on the other triangle. Look at these two triangles. I can place it exactly one on the other. Isn't it? See? It's placed perfectly one on the other, and so it is congruent. Now let me revert it back to the original position, and now let me name these triangles. The first one, let's call it ABC. The first triangle ABC, and it is represented like triangle ABC. And the second triangle, let it be named PQ and R. So this is triangle PQR. Now look at the sides which are same. So what does congruence actually mean? The corresponding angles and the corresponding sides are the same, isn't it? That is how congruence is defined. When you either shift it, or you flip the triangle, or you rotate it so as to put it on top of the other. You are allowed to do these three things: shifting, flipping and rotating. So they are exactly the same, which means that the corresponding angles and the corresponding sides are the same. Only then you say that the two triangles are congruent. Now let's learn how to represent this congruence. So if all this is done, shifting, rotating, flipping, and we find that they are congruent, can I write it as triangle ABC is congruent to, this is the symbol which we use for congruence, and equal to, and a small S-like thing, a wavy thing on top of the equal to sign. So can I write it as, because I have shifted it and I have placed it on the other and I have found it to be congruent. So can we say this? Let's now explore. Let's verify. Now for that purpose, I am going to highlight these the sides of the triangle in colors. Now I am going to put AC in red. AC is the side which is opposite to the only obtuse angle of the triangle. So here the only obtuse angle is Q. So by this we mean that angle B is equal to angle Q, right? And the side opposite is PR, right? So this is the, sorry, I think the line is not, but still our purpose is to highlight it in red so as to understand whatever we are going to write now with more clarity. So AC and PR are equal, right? And what about, let me put AB in white, and the corresponding side would be just next to the obtuse angle. It should be RQ because the sizes look the same. They have to be the same. So this is in white, and let me take blue as my next color. So BC, this side BC and side PQ. Sorry, but still it's highlighted in blue, right? So PQ and BC should be the same. Now let me start writing. First thing which I found was AB was equal to, let me take it as AB is white in color, A is next to the red one, so it has to be written as RQ. Right, and if I say that the measurement or the length of side AB is equal to side RQ, I can very well write it as the line segment AB is congruent to the line segment RQ. Similarly, BC is equal to QP. See, I am not changing the order, I am going as it is, this order. And here also it is this A, B, C in that order. So if BC is equal to QP, I can say BC, the line segment BC is congruent to line segment QP. As I said, in lines we just have to check the lengths, then they become congruent if they are equal. And what about CA? I am writing it as CA as I am going in that order, A, B, C. CA should be equal to PR. Isn't it? Or in congruence, the line segment CA is equal to the line segment PR. And now we already saw that angle B is equal to angle Q. Now what would angle C be equal to? It would be equal to the angle between the blue and the red line. So the angle between blue and the red line would be angle P, and the remaining angle is of course A, and this should be equal to angle R. So if I have to write this very clearly, I should be writing angle ABC, isn't it, which is denoted by this obtuse angle. Angle ABC is equal to angle RQP. This is how we write angles also, isn't? The angle which we talk about should be in the center. So what I mean here is the measure of angle B is equal to the measure of angle Q, which means that angle B is congruent to angle RQP. ABC is congruent to angle RQP. Similarly, the measure of angle C is equal to the measure of angle P, which means that angle BCA is congruent to angle QPR. See, P is placed in the center here and C is placed in the center in the first one which we wrote, angle BCA, and the one which is remaining, angle CAB, is congruent to angle PRQ. Right? So these are the three angles which are congruent, and these are the three sides which are congruent. Now corresponding sides and corresponding angles are equal, hence these two triangles are congruent. But now the question which we raised in the beginning was, can I write it this way? Triangle ABC is congruent to triangle PQR. Does it correlate with whatever I have found? I found that AB is equal to RQ. AB is here, so RQ must have been here, but it is not that way. It's written as QR, right? And if you check the other ones also, you would find the same controversy. Now look at the angles. Angle B is equal to angle Q, it's placed in the center. But angle C is equal to angle P. But the one which is corresponding to angle C here is angle R. So we should not write it this way. Instead, when we talk about congruence of these two triangles, of course we have checked for the congruence, the angles are the same, the corresponding sides are equal in length, but how should we represent it? We should represent it as triangle ABC is congruent to triangle RQP, right? So now if you start matching with whatever we have discovered here, we would find that they all correlate with one another. And look at the angle itself, the way it is defined. ABC is congruent to RQP. So I hope you have learned how to represent symbolically the congruence between two triangles. It is not just enough if we see that the corresponding sides and the corresponding angles are equal. We should be writing it in this way properly. And now, having got a very good idea of what congruence is, do we have to say that every time that three sides and three angles when I say 3 sides and 3 angles, of course I'm talking about the corresponding 3 sides and the corresponding 3 angles. Should we always check for 6 measures to be equal, and only then declare that the triangles are congruent? We are going to dwell further around this question. Are 6 measures supposed to be equal to conclude that 2 triangles are congruent? Let's explain this in our next video onwards. Thank you.